So here I'd like to look at how we can solve linear equations. And first of all, before we do that, we know that the word linear has to do with the power of x. So a linear, say, expression, for example, we've already talked about linear expressions, is where the highest power of x is 1. So if you like, 3x plus 5 is an example of a linear expression. Not linear is when you've got fractional indexes. So if you had 3x plus 2x to the 2/3, that's not linear because powers of x have to be, for a linear equation, have to be whole numbers, and this is not a whole number. 3x plus 2x squared, that's not linear because the highest power of x here is 2. So linear expression is where the highest integer power is equal to 1. So here we've got 3x plus 5. So this expressions are made up of terms that are connected by pluses and minuses. And so we've got two terms in this linear expression. The two terms are 3x plus 5. Now, a linear equation is when we introduce an equal. So, for instance, if we had 3x plus 5 is equal to 11. Okay. What we've got here is we've got a linear expression over here equals some number. So we want to find all the values of x so that when that value of x is multiplied by 3 and we add 5, we're going to get the number 11. Think of equations, particularly linear equations, like the old beam balance. The beam balance was basically had two sets of pans or dishes on the side. You had a solid bar and you had a balancing thing here. For this to balance, we needed to have the same weight on each side. That way it would balance perfectly horizontally. If we added another weight on that side, we had to add the same weight on the other side. Then it would balance. If we took away two of these, you know that wouldn't balance, so you'd have to take away two of these on this side, and then it would balance. Now, equations are exactly the same. Whatever we do on the left-hand side, so this is the left-hand side, if you like, I'll abbreviate that with LHS, and this is the right-hand side. So we've got LHS and RHS, left-hand side, right-hand side of the equation. So whatever we do on one side, we've got to do to the other. The other important concept is that we tend to try and get the unknowns, the terms containing the unknowns by themselves, and everything else on the other side. So looking at this linear equation here, we've got a term containing x, 3x. So we want to get rid of this plus 5 and get it over to the other side. So what we've got to do is to subtract 5. Take 5 off. If we add 5 and subtract 5, that's the same as just 0. But we've taken something off the left-hand side, so we're going to take 5 off the right-hand side. That'll leave us on the left-hand side with 3x. Plus 5 minus 5 is 0, so you don't put plus 0. Equals 11 minus 5 is 6. We know that 3 is connected to the x by a multiply. So the opposite of multiplying by 3 is to divide by 3, and that's a way to divide. So if we divide that side by 3, we've got to divide this side by 3. Why did we divide by 3? Because 3 into 3 goes once, 3 into 3 goes once. Once x is x over 1, x over 1 is just x, equals 6 over 3 is equal to 2. And there's our answer. So our original equation was 3x plus 5 equals 11. With all of these, you should be looking to check your answer. You should know that if you've got the right answer or not. So we actually write down check left hand side, and we write down what the left hand side was, which is 3x plus 5. We now substitute in our x value that we got for an answer, so that's 3 times 2 plus 5, and that's equal to 3 2s are 6 plus 5 is 11. The right hand side, go right back up to the original question, and this was the original question here. The right hand side equals 11, and you should find that they are both the same. And if they are, you know the answer is correct. So the principles are fairly straightforward. Linear equations are the easiest equations to solve. They're a little bit more complicated than that, but we'll do those a little bit later. Think of the balancing thing. Whatever we do to one side, we've got to do to the other. We try to isolate the term containing x by itself. And when we do get an answer, we should check to see that our answer is correct by substituting in the left-hand side and right-hand side. And hopefully the left-hand side will equal the right-hand side. You know you're correct.